not the change.
Negative 60.
30 units in.
Meters per second.
Yeah. We're going from 30 to negative 30. There is a change. Think of a number line. I got 0 here, I got 30 here, I got negative 30 here. I'm asking, what is the change? It's negative 60. Or, you can look at it from the point of view of my final minus my initial, so negative 30 minus 30. Now, the acceleration we know already, but this is sort of a confirmation to see if we sort of went awry somewhere. So we find acceleration through, as before, change in velocity over change in time. And I get negative 60 meters per second divided by 10 seconds. And I get the number that we started with, that was given in the problem. So feeling like we've done something right. At what time did the object stop? Yes. So we've already got it from that, or doing the math bit. I know that the acceleration, change in velocity over change in time. So this is negative 6 is equal to 0 minus 30 divided by t, or negative 6 is equal to negative 30 over t. Two fractions equal to each other, you multiply the diagonal you know, divide by what's left over, and you get 5. And then the average speed. Oh wait, no, we haven't gotten the distance yet. So I know it stops at 5 seconds. What was the distance traveled? Hint, the answer is not 0. If that were the case, then if you sold your car at the same dealership that you bought your car, you'd be making the claim that it hasn't been driven at all. Because the distance traveled is 0. Which we know is not the way that it works.
Would it be 60?
Be what?
60, maybe?
How'd you get to 60? It felt right.
Yeah.
It's not 60.
Okay.
We have to do the same thing we did last time. We have to figure out how far did it go before it stopped. Well, I know it starts out at 30 meters per second, and it stops at after 5 seconds. What's the average speed? Or average velocity? If I go from 30 to 0, what's my average? So I travel on average 15 meters per second for 5 seconds. How far did I go?
75 meters.
So I started at some particular place here. I went 75 meters before I turned around, and then I ended up going back to where I started. What was the distance traveled?
350 meters.
And now to find average speed. Oh, distance over time. Questions here, because I'm about to make it a little more complicated.
Time to finish writing it down.
Sure.
That's okay.
On the test, do you want us to write out like the equations, or can we just write out like, I guess 150 over 10?
Somewhat a double-edged sword. The more you write, the more chance you have to make a mistake, but the more chances you'll have of getting partial credit. So I prefer, if you I prefer the equation than the numbers than the answer. But, you know, it's however your mind is working at the moment.
I'm so confused how you got, what distance did the object go?
Okay, the distance the object went is I have to, from where I started, think of it like a car. I travel some distance out and then I travel back. So even though I've ended up not going anywhere in the end, that's why my displacement is 0, I did go somewhere. So I have to figure out how far did I travel out before I turned around. So the way of figuring out how far you travel out, since scalars, changing direction doesn't change the scalar. And that was badly worded. Vectors have this nice thing where I can ignore what happens in between. I just care about what's happening at the end based upon some initial conditions. Distance, I do have to worry about how I got there. So with these problems where I've got a turnaround, I'm going out a certain distance, I turn around, I come back, I need to figure out how far did I go out. So if I start out at 30 meters per second and I know I turn around, I'm going 0 meters per second, I'm just finding, the first thing I do is I find the average velocity. I'm only traveling in one direction, that's also the average speed for that section. So my average velocity, 15 meters per second. Then I multiply times the time. Well, it took me 5 seconds to stop. So that times 5 seconds gets me 75 meters out. And then, since I end up back where I started, 75 meters to get back. Did I address the question that you had?
Yes.
You're not sure of that.
Yeah. How do you get 15 meters per second?
When I find, if acceleration is constant, I can find an average velocity just by averaging the first and last. So I just average 30 and 0. Other questions? All right, you resolved your question?
I was trying to figure out how you got 150 meters, and then I realized you had to go back.
Yes.
This way 75 and then back 75.
Absolutely. All right, let's make it look hard. We'll keep our 10 seconds, that's fine. Let's see, let's get rid of that last sentence again, we'll keep our initial conditions the same.
No. Sorry.
Do I need to write anything back?
No.
Okay, well, she's getting the last of that
Okay,
down.
I'm good now.
After 10 seconds. It's going. Let's see, so the numbers don't work out too perfectly. Let's go with negative 24 meters per second. Oh, basically, we'll keep the first question in there. The first question, something like this, if I did that on the test, when I think about it, I put a little gift icon next to it. If you ever see the gift icon, that is, the answer probably is in the question. So, what's the final velocity? Come on, everybody, in unison.
Negative 24 meters per second.
Wow, it sounded like a single voice. That's good. Now, I know this is a velocity because I have a negative in front of it. Speed's not gonna have a negative in front. I know that's a velocity because I called it the velocity. I could have also indicated velocity by putting a plus in front of it. What is the final velocity? So negative 24 meters per second. All right, so now we're back to the questions that we had. So this is 30 here. And this part will put it easier. Now, what's the average velocity?
Negative 14.
How'd you get that?
I did 30 meters per second minus negative 24.
That gives you positive 54. All right, let's jump ahead for just a second. You answered a different question. What's the change in velocity?
Negative 54.
Units?
Meters per second.
There we go, yes. So it's final minus the initial, so negative 24 minus 30.
Wait, what did you ask?
I initially asked what's the average velocity. You answered this one.
Oh,
You were ahead of your time.
okay, yeah.
So while we're here, so the change in velocity, it's supposed to be the V, is the final minus the initial. So negative 24 minus 30, negative 54 meters per second, as Genesis said. All right, so back to average velocity.
Oh, okay, I see what I did. Three meters per second.
How'd you get that?
I did 30 plus negative 24. That gives you 6, and then you divide that by 2.
Yes. You just find the average of those two numbers right there. So I get 30 plus negative 24 divided by 2, 6 divided by 2, or 3 meters per second. All right, so I know my average velocity is 3 meters per second. What is my displacement then? All right, Kinsey, you look like you want to say it.
Me?
Yes.
I don't know.
If nothing else, since it's recorded, I've given you an alibi.
The average velocity? So it would be 3 meters per second. Wait,
Looking for displacement.
okay, yeah. So 3 meters per second times the, 10 seconds?
Yep. And you get
30? 30 meters per second. Remember 30 meters?
30 meters. So it's the average velocity times time. So it's 3 meters per second times 10 seconds. 3 meters per second times 10 seconds, and you get 30 meters. And just to let you know that, again, I can make anything a fraction there. The seconds, I have a second on the bottom and a second on the top, they cancel out, so that's why it's just meters in the end. Change in velocity you already have. What is the acceleration? Stop for a second. Telling myself to stop. Are there any questions up to here? All right, now, what is the acceleration, or how do we find it?
Change in velocity over change in time.
Okay, therefore, we have all the parts in front of us. change in velocity, you should know.
Yes, -54.
And change in time?
10 seconds.
I'll write down 5.4 because that part will be written down. Two things missing.
Oh, meters per second.
I don't know.
Still two things missing.
Negative
That's one of them, yeah, it's negative.
seconds.
That was the big thing.
Meters per second squared.
Yes, and you forgot the square. Meters per second squared. So now, this is the part, and all of that is pretty much what we did before. Now's the part where, unless I picked it out wrong, it is not gonna stop on one of the seconds. It's gonna stop somewhere in between.
Yep.
So let's just go through that part. So if I start out at 30 meters per second, how much is my velocity gonna change every second?
Negative 5.4.
Yeah, so negative 5.4 meters per second every second. So if I started at 30, and then it comes down to, you need to use a calculator, or can you do it in your head?
24.6. 23.2.
Wait,
I'm at 19.2.
okay.
Want to keep doing it? 13.8. 8.4. 3.
It's okay if you just write 3 there. Then negative 2.4.
Meters sounds like negative 13.2, negative 18.6, and
Wait,
negative
13 point, yes, 2, sorry. And then negative 18.6,
yes, and then negative 24.
and negative 44, okay. So we ended up where I expected. I expected us to end at negative 24. We ended at negative 24, feeling good. If there's some error in here, it's, all right, but I narrowed it down between what 2 seconds will it stop?
5 and 6.
Okay. If you at least acknowledge that on a test, you get something. Now, it's not gonna be perfectly split between them. It's not 5.5. Is it gonna be closer to 6 or closer to 5?
Closer to 6.
Indeed. Going from this to 0 is a bigger change than going from 0 to here. So most of it is going to be, it's gonna be closer to 6, a little bit closer to 6 than it is to 5.
6.
I don't suppose all of you were taught interpolation, or any of you were taught interpolation. Pre-calculator exercises. Because the tables didn't necessarily cover all the stuff in between. All right, so we don't do interpolation. We have some idea what the answer is. So for those who are panicking a little bit at the math, at least if you can get me closer to 6 than to 5, you'll get something for it. If you want to be a little bit more precise, well, I know my acceleration is my change in velocity over change in time. So I have negative 5.4 is equal to negative 30 divided by time. I go from 30 to 0, so my change is negative 30. And so time will end up being 30 over 5.4. Please don't leave it in that form. 1 fraction bar per answer, and I consider the decimals like a fraction bar. And you have calculators. And if you don't have a calculator, I can lend you a calculator on days of test. Or if you let me know before class, I can go grab one. So what is this?
It's 5.555.
It is a little bit closer to 6 than it is to 5. Feeling good that I expected somewhere in there. Now to figure out how far does it go, well, I know it starts out at 30 meters per second. It turns around at 0 meters per second after 5.55 repeating seconds. Same steps as we did before. What's the average velocity? Over that amount of time, you multiply them, and you get somewhere around 82, 83 ish.
Yeah.
We'll just say 83. I know I end up, where's my displacement? 30 meters. I end up 30 meters from where I started. So I go out 83 meters to get to here. I have to cut back 53 meters to get to here. So the total distance traveled is just the sum of those divided by the time, you get the average speed. So that's the distance traveled. And then 136 meters over 10 seconds, 13.6 meters per second. There are a number of problems where I do 3 where I give you initial and final velocity and time, and then 3 where I give you, I think, initial velocity, displacement, and acceleration, or time and acceleration. So they are posted on Blackboard under, I think, supplemental materials for extra practice. I'm pretty much done with chapter 3. So today is the 10th. Why don't we say master set for chapter 3, the 17th, a week from today.